The first objective is to investigate the relationship between the Reynolds number and drag coefficients of different drag models. The second objective is to investigate the relationship between the angle of attack and the lift and drag coefficients for aerofoil with closed and open flap arrangements. And the third objective is to compare the drag and lift coefficients of the different shapes with those published in literature and discuss the different applications of using the wind tunnels. Manometer zeroing. The experimental procedure begins with airspeed manometer zeroing to null position. This can be done by turning the small knob in a clockwise direction to raise the manometer fluid to the null position. Using the two-component balance. The wind tunnel is equipped with a two-component aerodynamic balance that measures both the lift and the drag components of the force exerted on the model under testing. The two-component balance consists of a pair of balances supported on knife edges on mutually perpendicular axes parallel to and normal to the axial center of the tunnel. Lift and drag components of force exerted on the models under testing are balanced by sliding weights along the arms of the balance until a state of null deflection is reached. The angle of attack should be set to a certain value using the protractor fixed on top of the two-component balance before setting the balance to the null deflection position. Preliminary measurements. Before starting testing the different models, several preliminary measurements should be done to gather the required data to calculate the air density. These measurements are the room temperature, the parametric pressure, and air relative humidity. These data can be taken from the digital weather station installed in the lab. As a part of the preliminary measurements, relative air humidity can be measured by using the hygrometer or the sling psychrometer and the psychrometric chart. The sling psychrometer consists of two thermometers mounted together with a handle. The other has a cloth wick over its bulb attached to a water container and is called a wet bulb thermometer. When a reading is to be taken, the water container should be filled with distilled water. The sling psychrometer is whirled around for about 1 to 1.5 minutes. After that, the temperatures of both thermometers are read. During the whirling, the water evaporates from the wick, cooling the wet bulb thermometer. The relative humidity can be determined using the measured dry and wet bulb temperatures and the psychrometric chart. Part 1. In Part 1, the drag models will be tested to calculate the drag coefficients using fixed angle of attack and variable air speed. To run this test, we start with measuring the equatorial diameter of the 5 drag models. All the models have the same equatorial model and as a result have the same projected cross-sectional area. Similar projected area enables a direct comparison of the drag forces and coefficients of the drag models. Select the drag model and open the test section in the wind tunnel. Mount the required drag model in the lift and drag balance. Make sure that the balance is at the null position. Also make sure that the angle of attack is 0 on the protractor for all tests in Part 1. All these arrangements should be done with no airflow to provide axis symmetric flow over the model. Close the testing section and don't forget to close the slot in the tunnel base using the cover plates to reduce airflow turbulence. Make sure that the motor is set to forward direction before turning on the motor. Turn the AC motor on and slowly increase the motor speed and stop when the manometer indicates the required air speed. The drag force exerted on the model will move the model from its original null position. The drag force can be obtained directly in newtons using the two-component balance. The drag force can be read directly using the balance by moving one or both masses on the balance. If moving the small mass will not return the balance to the null position, the lower mass should be moved one increment of 0.5 newtons. This can happen at high airflow speeds. The new position of the two masses indicates the drag force at a certain airflow speed. For each drag model, repeat the test at different airflow speeds, ranging from 12 meters per second to 26 meters per second, with a fixed increment of 2 meters per second. Repeat drag force measurements for the 5 drag models using the same speeds. Don't forget to follow the same steps to set the model for testing. In order to give accurate results for drag force measurements, it is necessary to measure the net drag force on the model by subtracting the drag force resulted from the support rod. Therefore, run the drag force test on the spare support rod at the same testing conditions and plot the support rod drag versus airflow speed. The appropriate drag force of the spare support rod may then be deducted from the total drag forces measured for a particular model, and support at a given airspeed to get the net drag forces on the model at that speed. Using the net drag forces at different airflow speeds, calculate and plot the drag coefficients versus Reynolds numbers for all the drag models on a single graph. Part 2. This part of the experiment is to study the effect of the angle of attack on drag and lift forces exerted on an aerofoil model with closed flap and open flap arrangements. In these two cases, the following procedures should be followed. Measure the dimensions of the different parts of the aerofoil, including the full angle of opened flap. These dimensions will be used in calculating the projected cross-sectional area. It is important to note that the projected area will change with each angle of attack. Also, for a certain angle of attack, the projected area is different in cases of closed and open flap. Open the test section in the wind tunnel and mount the aerofoil model vertically in the lift and drag balance. Make sure that the two balance components are at the null position, as in zero force and zero angle of attack with no airflow. Run the motor fan at a constant speed for all runs. Set the airspeed at a certain value on the manometer and don't lower the speed to zero at the end of each run. You can simply turn the motor fan off and on to get back to the same airspeed. When measuring the drag and lift forces, it is important to reduce the slot in the tunnel base as much as possible, using the cover plates provided. In this part of the experiment, the Reynolds number should be fixed by fixing airspeed within the range of 18 to 25 meters per second. Drag and lift forces data are to be collected with different angles of attack. The angle of attack should be increased from 0 degrees to 30 degrees at constant increments of 2 degrees by turning the protractor on top of the balance. Repeat drag and lift measurement for the aerofoil model with full opening of the flap using the same air speeds. The results should be presented on a graph showing the drag and lift coefficients versus the angle of attack, with clear indication to the angle of attack at stall. As you know, the stall occurs at a certain angle of attack when a loss of lift force is accompanied with an increase in drag force.